So 3 part 2, so we're asked to integrate this function using this substitution. Let's start by writing du dx equals 2 or du equals 2 dx. Rearrange this to get x equal to 3 across divided by 2, so x equals u minus 3 over 2, let's get it right. So that will be for this x here, so we can substitute for x. I know it's 2 dx, so I think of 2 and I'll put a half outside, so I have a half outside, that's fine. And I've got the limits to do still, so I've got x equals 1, u equals 5, and x equals minus 1, u equals 1. So I'm ready to go, fully prepped, so I'm going to say this becomes half the integral between 5 and 1 of 3 lots of x, which is u minus 3 over 2, times by 1 over 2x plus 3 squared, or 1 over u squared, du. And I'll tidy this integral up, just move my paper so I can get a hold of it, it's better. So it's a half the integral between 5 and 1. No, I didn't really do much tidying up here, but it's just, so it's 3 over 2, u minus 3 over u squared du. Okay, I'm going to sweep my numbers out to the front, so I've got 1 times 3 is 3, and 2 times 2, which is 4, so I've got 3 over 4, the integral of u over u squared minus 3 over u squared du, between 5 and 1. So u over u squared is 1 over u, and 3 over u squared is u to the minus 2, so I'm sort of labouring this a little bit, going a bit slow, but never mind. So it's 3 over 4, the integral between 5 and 1 of 1 over u minus 3 u to the minus 2 du. 1 over u integrates to ln u, so it's 3 over 4, big square brackets, ln u, add 1 to power, divide by it, so plus 3 u to the minus 1 between 5 and 1. Which equals, if I sub in 5, I'm going to get 3 over 4 ln 5 plus 3 over 5 minus 3 over 4. Put in the 1, I'm going to get ln 1, which we know is 0, but I'll just write it for completeness, plus 3. So I'll factorise this, so in sense I've got 3 over 4, the ln of 5, and I've got 3 over 5 minus 3, well, minus 15 over 5, so I put some 5, so 3 minus 15 is minus 12, so minus 12 over 5, close brackets. I can go reasonably quickly on this bit, because ultimately I'm going to work out the value of that, and then I'm just going to grab my calculator, put that in, and make sure that that evaluates the same value as that, and now I've got it right.